For months, NASA has told us not to worry. They called 3I Atlas harmless, a piece of frozen debris passing quietly through our solar system. But last night, the agency switched to high alert mode. Telescopes retasked, communications encrypted, and one line quietly added to the mission logs: do not engage without authorization. The change appeared at 2:47 a.m. Eastern Standard Time on the public mission status page maintained by the Jet Propulsion Laboratory. Most people were asleep. Most astronomers were offline. But the internet never sleeps, and neither do the automated archival bots that capture every version of NASA's public-facing databases. The old entry read, 3I Atlas, Routine Observation Priority Level 3. The new entry, timestamped just minutes later, read 3I Atlas, Restricted Object Authorization Required for Data Access. No press release, no explanation, just a single line of text that transformed an unremarkable interstellar visitor into something else entirely. If it's safe, why the alert? The object we now call 3I Atlas was first detected on August 12 by the Asteroid Terrestrial Impact Last Alert System in Hawaii. The discovery was unremarkable at first, a faint smudge moving against the background stars, another piece of cosmic flotsam drifting through the void. Within 72 hours, orbital calculations confirmed what astronomers had suspected. This object originated from beyond our solar system. It was the third confirmed interstellar visitor after 1I Oumuamua and 2I Borisov, and like its predecessors, it appeared to be nothing more than a frozen relic ejected from some distant stellar nursery billions of years ago. The scientific community responded with measured enthusiasm. Papers were written, observation time was allocated, graduate students updated their dissertations. 3I Atlas became a minor celebrity in the astronomy world, but not a headline. It was following a predictable hyperbolic trajectory, moving too fast to be captured by the sun's gravity, destined to pass through our neighborhood and disappear back into the interstellar medium. The brightness measurements suggested a dark, irregular surface consistent with a carbonaceous composition. The spectroscopic data showed water, ice, and organic compounds, exactly what you'd expect from a comet-like object formed in the protoplanetary disk of another star. Everything was routine, everything was explainable, everything was safe, until it wasn't. The first hint that something had changed came not from NASA's official channels, but from an archived Slack conversation leaked by someone inside the Jet Propulsion Laboratory. The messages, posted to an encrypted file-sharing service late Tuesday evening, contained fragments of internal discussion between members of the Near-Earth Object Studies team. The timestamps indicated the conversation occurred approximately 18 hours before the public status change. One message read, "Motion residuals are increasing. Non-random signature confirmed by 3 independent tracking stations." Another, "We need to rerun the ephemeris. The acceleration vector doesn't match outgassing models." And then, most unsettling, "Who authorized the comms blackout? This needs to go up the chain immediately." The conversation ended abruptly. No follow-up messages, no resolution, just silence. Non-random acceleration. Those 2 words carry significant weight in the world of celestial mechanics. When an object moves through space, its trajectory is determined by gravity and momentum. Asteroids and comets follow predictable paths governed by Newton's laws and Einstein's refinements. Sometimes comets exhibit non-gravitational acceleration when sunlight heats their surfaces and causes jets of gas and dust to vent into space, creating a subtle rocket effect. But these outgassing events are well-understood phenomena. They produce characteristic brightness variations as the comet rotates and different surface features are exposed to sunlight. They create visible comas and tails. They follow predictable patterns based on the object's distance from the sun and its composition. Non-random acceleration means something else entirely. It means the object is changing velocity in ways that cannot be explained by known physical processes. It means the trajectory is being altered by forces that shouldn't exist. If it's safe, Why the deviation? Independent observatories began reporting anomalies on the same day the leaked conversation took place. Amateur astronomers with backyard telescopes, citizen scientists with access to university facilities, professional researchers at institutions not directly connected to NASA's observation network, all of them started noticing the same thing. 3I Atlas was not where it was supposed to be. The discrepancy was small, measured in arcseconds, but it was growing. By Wednesday evening, the positional error had exceeded the margin for measurement uncertainty. By Thursday morning, it was undeniable. The object was accelerating. Dr. Elena Vasquez, an astronomer at the Cerro Tololo Inter-American Observatory in Chile, was one of the first to speak publicly about the discrepancy. In a series of posts on a professional astronomy forum, she described her observations with careful precision. She had been tracking 3I Atlas as part of a research project studying the composition of interstellar objects. Her team had taken multiple high-resolution images over a 5-day period, measuring the object's position against the background star field with sub-arcsecond accuracy. "The positional residuals are significant and systematic," she wrote. "This is not measurement noise. The object is deviating from the predicted ephemeris in a way that suggests continuous acceleration. We checked our calibration, verified our astrometry against multiple reference catalogs, and consulted with colleagues at other facilities. Everyone is seeing the same thing." She concluded with a question that would echo across the astronomy community. "Has anyone been able to reach the JPL team?" "They're not responding to queries." They weren't responding because they had gone silent. The official NASA communication channels remained operational. Press releases about Mars rovers and lunar missions continued to flow, but anything related to 3I Atlas had been placed under what one anonymous source described as administrative review. Requests for observation time at NASA-affiliated telescopes were being denied without explanation. Data from the Hubble Space Telescope and the James Webb Space Telescope, both of which had been scheduled to observe the object, were suddenly classified as preliminary and withheld from the public archive. The silence was coordinated, deliberate, and unprecedented. If it's routine, why the silence? The electromagnetic interference was detected on Friday. Multiple ground-based radio observatories reported anomalous signals in the UHF and microwave bands, lasting between 30 and 90 seconds, occurring at irregular intervals. The signals appeared to originate from a region of sky near the sun's limb, the apparent edge of the solar disk as viewed from Earth. Triangulation suggested a source location consistent with the predicted position of 3I Atlas. Radio interference near the sun is not unusual. Solar flares, coronal mass ejections, and other forms of space weather produce electromagnetic emissions across a wide spectrum. But these signals were different. They were narrowband, highly structured, and repeated with subtle variations in frequency and timing. One radio astronomer described them as almost coherent, like someone tuning a radio through static. The National Radio Astronomy Observatory issued a brief statement acknowledging the detection of unusual radio emissions and attributing them to solar activity under investigation. The statement was carefully worded, technically accurate, and completely uninformative. Solar activity was indeed under investigation, but so was the object passing through that activity. Amateur radio operators, unconnected to official astronomy channels, began reporting similar phenomena. A network of shortwave enthusiasts detected brief bursts of interference that disrupted communications in the 20-meter and 10-meter bands. The interference occurred simultaneously across multiple geographic locations, suggesting a source in space rather than terrestrial transmitters. Several operators attempted to analyze the signal structure using spectral analysis software. The results were inconclusive, but intriguing. The signals exhibited patterns that some described as structured or modulated, though no one could definitively rule out natural causes. One operator, posting under a pseudonym on a ham radio forum, noted something peculiar. The timing of the bursts correlates with the predicted position of that new interstellar object. Might be coincidence, might be something else. If it's safe, why the interference? The civilian satellite networks were redirected on Saturday morning. Without announcement or explanation, multiple commercial Earth observation satellites operated by private companies adjusted their pointing angles, shifting away from their scheduled imaging targets. The changes were small but coordinated, affecting satellites owned by different corporations with no obvious connection beyond their shared orbital parameters. One employee at a satellite imaging company, speaking anonymously to a space industry news blog, described the redirect as unusual and unexplained. According to this source, the company received an official request from the National Oceanic and Atmospheric Administration to temporarily modify its observation schedule to avoid potential interference with sensitive research. The request was labeled as routine space weather precaution, but the timing was suspicious. Space weather warnings are typically broadcast publicly through established channels. This request arrived through encrypted communication and included a non-disclosure clause. Other companies received similar requests. One satellite operator confirmed to journalists that they had been asked to temporarily avoid imaging specific coordinates in cislunar space. When pressed for details, the operator declined to comment further, citing contractual obligations. The pattern was clear. Something was happening near the trajectory of 3I Atlas, and someone wanted to control who could observe it. If it's routine, why the redirection? By Sunday, the astronomy community was divided between skepticism and alarm. Official statements from NASA continued to describe 3I Atlas as a routine interstellar object under ongoing observation. But the gap between official language and observed behavior was widening. Some astronomers publicly dismissed the concerns, arguing that the positional discrepancies could be explained by previously undetected outgassing or measurement errors compounded by the object's low brightness. Others were less confident. Private conversations revealed a growing unease among researchers who had direct experience with interstellar objects. Dr. Avi Loeb, the Harvard astronomer who had famously suggested that Oumuamua might be an artificial object, weighed in with characteristic directness. In a blog post titled "When Trajectories Don't Match Predictions," he analyzed the available data on 3I Atlas and noted several troubling features. The acceleration pattern was inconsistent with cometary outgassing. The lack of a visible coma or tail suggested minimal volatile activity. Most significantly, the direction of acceleration did not align with the sun. Outgassing typically pushes objects radially away from the heat source, but 3I Atlas appeared to be accelerating tangentially, changing its velocity vector rather than simply being pushed outward. "We must consider all possibilities," Loeb wrote. "Natural explanations should always be our first hypothesis. But when natural explanations require increasingly contrived assumptions, we must remain open to alternatives." The motion pattern of 3I Atlas is more consistent with an object under powered propulsion than with passive drift affected by solar radiation or outgassing. He stopped short of saying the word engineered, but the implication was clear. The scientific community responded with predictable division. Some praised Loeb's willingness to consider unconventional hypotheses. Others accused him of sensationalism and premature speculation. But beneath the public debate, a quieter conversation was taking place. Several prominent astronomers began reaching out to colleagues with access to classified or restricted data. Questions were asked in carefully neutral language. Have you been able to confirm the latest positional measurements? Has anyone received updated orbital elements? Why has the JPL Horizons database stopped providing ephemeris predictions beyond next week? No one had good answers. Everyone had more questions. If it's safe, why the speculation? The 48-hour blackout began on Monday evening. The timing was precise and coordinated. At 6 p.m. Eastern Time, every major space agency website simultaneously displayed maintenance notifications. NASA, ESA, JAXA, Roscosmos. All of them went into what they described as scheduled network maintenance. Public data archives were temporarily inaccessible. Live telemetry feeds went dark. Press offices stopped responding to inquiries. The timing was impossibly coincidental. Space agencies coordinate international collaborations, but they operate on different technical infrastructures, different time zones, different administrative procedures. The probability of simultaneous unplanned maintenance affecting all of them at once was effectively zero. This was deliberate. This was synchronized. Amateur astronomers and citizen scientists scrambled to fill the void. Without official data, they relied on their own observations. Telescope time at university observatories was hastily arranged. Backyard observers with sensitive cameras stayed up through the night, capturing images of the region where 3I Atlas should be visible. The collaborative effort was impressive, a grassroots response to institutional silence. But the object was faint, moving rapidly, and increasingly difficult to track without precise ephemeris predictions. By Tuesday morning, multiple independent observers reported that they had lost visual contact. The object should have been magnitude 16, easily visible with moderate-sized telescopes. Instead, it had either faded dramatically or moved significantly from its predicted position, or both. One astronomer, posting anonymously, described the situation with stark clarity. "We're flying blind. Without updated orbital elements, we're basically guessing where to point. And even when we point at the right coordinates, we're not seeing anything. Either the object has changed its reflectivity, or it's not where it's supposed to be." The blackout ended exactly 48 hours after it began. At 6 p.m. on Wednesday, space agency websites came back online with cheerful messages thanking users for their patience during routine system upgrades. But the data archives remained incomplete. Historical observation records were available, but recent measurements were conspicuously absent. The JPL Horizons database resumed providing ephemeris predictions for 3I Atlas, but the trajectory had been updated with new parameters. The object was now listed as having uncertain non-gravitational forces affecting its motion. That single phrase represented a seismic shift in classification: uncertain non-gravitational forces. In the vocabulary of orbital mechanics, this is the language used when an object's motion cannot be fully explained by gravitational physics alone. It's the asterisk in the data table, the footnote that says we don't actually understand what's happening here. If it's routine, why the uncertainty? The internal task force was confirmed on Thursday through another leak, this time from someone claiming to be a contractor working with NASA's Planetary Defense Coordination Office. The leak appeared on an encrypted messaging platform used by investigative journalists and included screenshots of internal documentation marked "for official use only." According to these documents, a classified review panel had been convened 3 days before the public status change, comprising experts from NASA, the Department of Defense, and several intelligence agencies. The panel's mandate, as described in the leaked material, was to assess potential national security implications of anomalous telemetry associated with Interstellar Object 3I Atlas. The language was bureaucratic and vague, but the implications were profound. National security implications. This wasn't just about science anymore. This was about threat assessment. The document listed several specific concerns under review: unexplained acceleration inconsistent with known physical mechanisms, electromagnetic emissions of uncertain origin, trajectory deviations suggesting possible course correction capability, unknown composition inconsistent with spectroscopic analysis of similar objects. Each bullet point was followed by redacted text. Whatever details the task force was considering remained classified. But the existence of the panel itself confirmed what many had suspected. NASA's public reassurances about 3I Atlas being routine and harmless were not matched by private concerns. One section of the leaked document stood out for its directness. Under a header labeled Communication Protocols, the text read, All public statements regarding Object 3I Atlas must be coordinated through the Office of Public Affairs in consultation with interagency partners. Personnel are reminded that unauthorized disclosure of classified or sensitive information is subject to administrative and legal penalties. This was not normal procedure for astronomical observations. This was crisis management. If it's safe, why the task force? The brightness curve stopped making sense on Friday. Astronomers who had managed to reacquire the object after the blackout noticed something strange about its appearance. The brightness was fluctuating in ways that didn't match the expected behavior of a rotating body with an irregular shape. Most asteroids and comets brighten and dim periodically as they spin, with the period of variation revealing their rotation rate and the amplitude of variation indicating how elongated or irregular they are. 3I Atlas had initially shown a rotation period of approximately 6 hours, with brightness variations of about 30%, typical values suggesting an elongated object tumbling through space. But the latest observations showed something different. The rotation period had apparently changed to 8 hours, and the brightness curve had become more erratic, with sudden spikes and drops that didn't follow any predictable pattern. "This doesn't make physical sense," wrote one observer in a detailed analysis posted to an astronomy preprint server. "Objects don't just change their rotation rates without experiencing torque from some external force, and the brightness variations we're seeing now look less like rotation and more like something else. Surface features appearing and disappearing, components separating. I don't know. It's not behaving like a rock." The analysis included photometric data showing the object's brightness over a 2-week period. The early measurements formed a clean sinusoidal curve, exactly what you'd expect from a rotating irregular body. The recent measurements looked like random noise superimposed on a declining trend. Something about the object's physical state had changed. Several astronomers suggested that 3I Atlas might be fragmenting, breaking apart due to thermal stress or rotational instability. Comets sometimes disintegrate when they approach the sun, torn apart by tidal forces or structural failure of their weakly bonded ice and dust. But 3I Atlas was far from the sun, well beyond the orbit of Mars, and moving away. Thermal stress should be decreasing, not increasing. And fragmentation events typically produce debris clouds that are easily visible in telescopic images. No such debris had been detected. Another hypothesis suggested that the object might be venting material in asymmetric jets, creating a flickering appearance as different active regions turned toward and away from Earth. But spectroscopic observations had failed to detect any evidence of a coma or outgassing. The object remained stubbornly dark and apparently inert, even as its brightness fluctuated in increasingly bizarre patterns. "We're missing something," concluded the analysis. "Either our understanding of the object's physical nature is fundamentally wrong, or something about it is actively changing. If it's safe, why the transformation?" The Harvard paper appeared on Monday morning. Published in the Astrophysical Journal Letters with a submission to publication time of just 6 days, extraordinarily fast by academic standards, the paper presented a comprehensive analysis of 3I Atlas's trajectory and argued that conventional explanations were insufficient to explain the observed motion. The lead author was Avi Loeb, joined by 2 colleagues from the Harvard-Smithsonian Center for Astrophysics. The paper's abstract was carefully worded but unambiguous. "We analyzed the astrometric and photometric data for interstellar object 3I Atlas and find that its trajectory cannot be reconciled with gravitational dynamics alone. The observed acceleration vector exhibits characteristics inconsistent with solar radiation pressure, outgassing, or other known non-gravitational forces." We discuss several hypotheses, including the possibility that the object possesses a propulsion mechanism of artificial origin. The phrase, "propulsion mechanism of artificial origin," sent shockwaves through both scientific and mainstream media. Within hours, the paper was trending on social media platforms. Science journalists scrambled to cover the story. Cable news networks booked segments with space experts. The narrative that had been building for weeks suddenly crystallized into a single explosive question. Could 3I Atlas be an alien spacecraft? NASA's response was swift and dismissive. A statement released by the agency's Office of Public Affairs emphasized that extraordinary claims require extraordinary evidence, and noted that natural explanations for the object's behavior were still being actively investigated. The statement praised the rigorous scientific process while carefully avoiding any direct criticism of Loeb's team. The message was clear: stay calm, don't jump to conclusions, trust the experts. But the experts were divided. Some astronomers publicly criticized the Harvard paper as premature and sensationalized, arguing that insufficient data existed to rule out natural phenomena. Others defended Loeb's right to explore unconventional hypotheses, noting that science progresses by challenging assumptions and considering all possibilities. The debate spilled across academic forums, conference calls, and late-night emails. Beneath the public controversy, a quieter subset of researchers began taking the propulsion hypothesis seriously. If 3I Atlas was indeed underpowered control, what did that mean? Where was it going? What was its purpose? And most unsettling of all, who built it? If it's safe, why the propulsion? The second trajectory update appeared on Tuesday without fanfare or explanation. The JPL Horizons database quietly updated its ephemeris predictions for 3I Atlas, incorporating new astrometric measurements and revised orbital parameters. The changes were subtle but significant. The object's predicted position had shifted by several arc-minutes, a small angular distance, but enough to place it well outside the uncertainty bounds of previous predictions. More concerning was the updated velocity vector. The object was no longer following a simple hyperbolic escape trajectory. Instead, its path now curved in a way that suggested it was being continuously accelerated, the trajectory bending more sharply than gravity alone could explain. Orbital dynamicists, analyzing the new parameters, calculated that the object was experiencing constant acceleration of approximately 0.01 millimeters per second squared, small by human standards, but massive in astronomical terms. To put this in perspective, Oumuamua, the first confirmed interstellar object, had exhibited acceleration of similar magnitude, which had been tentatively explained by outgassing despite the lack of a visible coma. That explanation had been controversial but ultimately accepted by most of the scientific community. But 3I Atlas was showing acceleration without any of the expected signatures of cometary activity. No coma, no tail, no spectroscopic evidence of water or other volatiles, just steady, persistent acceleration in a direction that changed slightly over time. "This is beginning to look like course correction," observed one trajectory analyst in a technical forum. "Small velocity changes applied over extended periods. That's how you navigate through space when you're not in a hurry. That's how you adjust your approach to a target." The comment sparked immediate debate. A target? What target? If the object was under powered control, where was it heading? Extrapolating the updated trajectory backwards suggested that 3I Atlas had entered the solar system on a path that would take it relatively close to Earth, not dangerously close, but within a few million kilometers, close enough for detailed observation from our planet. If it continued on its current trajectory with persistent acceleration, it would pass Earth at a distance of roughly 0.05 astronomical units, about 20 times farther than the Moon, but well within the range where ground-based telescopes could observe it with extraordinary detail. If it's safe, why the approach? The Chinese disclosure came unexpectedly on Wednesday evening. Xinhua News Agency, the official state press agency of China, published a brief article announcing that the China National Space Administration had been monitoring unusual orbital characteristics of interstellar object 3I Atlas. The article quoted an unnamed CNSA official describing the object as requiring continued observation and international coordination. What made the statement remarkable was not what it said, but what it implied. China had been quietly observing the object using assets not publicly disclosed, and they were concerned enough to break with their usual pattern of silence on astronomical matters. The statement included no technical details, no data, no analysis, just a carefully worded acknowledgement that something unusual was happening and that international cooperation was necessary. Within hours, other space agencies issued similarly vague statements. The European Space Agency released a brief note confirming that ESA facilities were contributing to the International Observation Campaign for 3I Atlas. Roscosmos, Russia's space agency, mentioned the object in a broader statement about near-Earth object monitoring. Even India's space agency, ISRO, acknowledged that their telescopes were supporting collaborative research on the interstellar visitor. The coordinated messaging suggested behind-the-scenes communication and agreement. Something had prompted multiple governments to simultaneously acknowledge that 3I Atlas warranted special attention. The statements were carefully calibrated to inform the public without causing panic, to acknowledge concern without revealing too much. Space policy experts noted the unusual nature of the coordination. International cooperation on space matters typically involves formal agreements, public memoranda of understanding, and transparent data-sharing protocols. This felt different, more urgent, more secretive, more like crisis response than scientific collaboration. When space agencies start talking like diplomats, you know something serious is happening, commented one former NASA administrator in a television interview. This is the language of managed disclosure. They're preparing the public for something they don't want to announce directly. If it's routine, why the diplomacy? The infrared signature was detected on Thursday by the Spitzer Space Telescope's successor instrument aboard the James Webb Space Telescope. The observation had been scheduled months earlier as part of a routine survey program, but the data took on new significance in light of recent events. The infrared spectrum revealed something unexpected. 3I Atlas was warmer than it should be. Objects in space radiate heat based on how much sunlight they absorb and how efficiently they cool. At its current distance from the Sun, 3I Atlas should have been extremely cold, perhaps 150 Kelvin or less. Instead, the infrared measurements suggested temperatures closer to 250 Kelvin, still frigid by Earth standards, but significantly warmer than passive radiative equilibrium could explain. The excess heat had to come from somewhere. For a comet, the explanation would be straightforward. Sunlight heats the surface, causing subsurface ice to sublimate, and the escaping gas carries away heat through a process called sublimation cooling. But the heat would be accompanied by visible outgassing, and no such activity had been detected. The object was radiating more energy than it absorbed, with no apparent explanation. Some researchers suggested internal radioactive decay or residual heat from the object's formation billions of years ago. But the numbers didn't work. Radioactive heating produces far too little energy to explain the observed temperature. Primordial heat would have dissipated long ago in an object this small. The excess temperature required an active energy source, something inside the object generating heat. "There's something wrong with the thermal balance," wrote one infrared specialist in a technical memo that was later leaked. "The object is either much smaller than we think, which would make the temperature reasonable, but would contradict the brightness measurements, or it's producing internal heat through some unknown mechanism. Neither option is particularly comforting." The leaked memo included a speculative calculation that gained significant attention. If the excess heat came from a power source, say a reactor or energy system of some kind, the required power output would be on the order of megawatts. Small by human standards, but enormous for an object that was supposed to be an inert chunk of ice and rock drifting through space. If it's safe, why the heat? The gravity survey results were published on Friday in a restricted access bulletin distributed to orbital dynamics researchers and planetary defense specialists. The survey had been conducted using precisely timed radio signals transmitted to and from various spacecraft in the inner solar system, measuring subtle changes in signal frequency caused by gravitational perturbations. By analyzing these Doppler shifts, scientists could detect the presence and mass of objects passing nearby. The technique is normally used to study the mass distribution of planets and large asteroids. Applied to 3I Atlas, it yielded confusing results. The object's gravitational influence was weaker than expected based on its size and brightness. Either it was much smaller than telescopic observations suggested, or it was much less dense. The first possibility seemed unlikely. Multiple independent observers had measured the object's apparent size using angular diameter estimates and radar ranging. The measurements were consistent. 3I Atlas appeared to be roughly 400 meters across, about the length of 4 football fields. An object that size should have significant mass, at least a few million tons if composed of typical rock or ice. But the gravitational measurements suggested a mass of less than 100,000 tons, 50 times less than expected. To reconcile the observations, the object's density would have to be extremely low, comparable to aerogel or foam. No natural material in space has such low density. Even the most porous comets and asteroids have densities at least 10% that of water. 3I Atlas appeared to be almost hollow. "It's like measuring a beach ball," one gravity specialist commented anonymously. "The size is there, but the mass isn't. For a natural object, this doesn't make sense. But if you wanted to build a large structure with minimal mass, this is exactly what you'd do. Construct a shell or framework with most of the volume being empty space." The implications were obvious and deeply troubling. A large, low-mass object doesn't occur naturally in space. It occurs when someone builds something designed to be large and light. If it's safe, why is it hollow? The weekend brought another development, this time from an unexpected source. The Very Large Array in New Mexico, a radio telescope consisting of 27 dish antennas arranged in a Y-shaped pattern, detected a signal. The detection was brief, lasting approximately 3 minutes, and occurred during a routine observation session aimed at mapping background radio sources. The signal appeared at a frequency of 1.42 gigahertz, the famous hydrogen line, one of the most common and scientifically important frequencies in radio astronomy. What made the detection significant was not the frequency itself, but the signal's characteristics. Natural radio emissions from astronomical sources are typically broadband, spreading across a wide range of frequencies, or they're narrow but rapidly drifting due to the motion of the source. This signal was narrowband, stable in frequency, and showed a distinct pattern of amplitude modulation. The intensity varied in a regular, repeating sequence. The radio astronomers analyzing the data were cautious. Radio interference from satellites, aircraft, and terrestrial transmitters is a constant problem in radio astronomy. Before claiming an astronomical detection, observers must rule out all possible earthbound sources. The VLA team conducted extensive follow-up observations, checking for satellites in the beam, analyzing the signal timing, and comparing the detection to known sources of interference. The signal repeated twice more over the following 12 hours, each time lasting between 2 and 5 minutes, each time appearing when the VLA was pointed at the predicted location of 3I Atlas. The probability that this was coincidental interference aligned with a fast-moving astronomical object was extremely low. The VLA team prepared a telegram, a formal bulletin distributed to the astronomical community announcing time-sensitive discoveries. But before they could publish, they received a call from the National Radio Astronomy Observatory headquarters. The caller, identifying themselves as a program officer, requested that the telegram be delayed, pending verification and coordination with other observing facilities. The VLA team was told that similar signals were being analyzed by other groups, and a coordinated announcement would be more appropriate than individual reports. The telegram was never published. Instead, the detection became another piece of classified information, another data point withheld from public scrutiny. If it's routine, why the signal? By Monday, the situation had evolved from scientific curiosity to international incident. Rumors circulated through diplomatic channels about closed-door meetings between space agencies and national security officials. Journalists began receiving anonymous tips about classified briefings in which government scientists discussed contingency protocols for the object's approach. Defense departments in several countries quietly updated their space surveillance networks, redirecting tracking resources toward the region of sky containing 3I Atlas. The public narrative remained carefully controlled. Official statements continued to emphasize that the object posed no threat and that all observations were consistent with a natural, if unusual, interstellar visitor. Behind the scenes, a different story was unfolding. Intelligence analysts were reviewing the accumulated data and reaching conclusions that contradicted the public messaging. The object was not behaving naturally. Its trajectory, acceleration, temperature, mass, and electromagnetic emissions all pointed towards something other than a passive chunk of interstellar debris. One leaked intelligence assessment, published by an investigative journalism outlet with a reputation for credible sourcing, summarized the situation with stark clarity. Object 3I Atlas exhibits multiple characteristics inconsistent with known natural phenomena. While a definitive determination cannot be made without additional data, the preponderance of evidence suggests the object may be of artificial origin. Recommend elevated monitoring and preparation of response protocols pending closer observation during Earth flyby. The document was marked secret and dated 5 days prior. Its publication created an immediate media firestorm. Government officials refused to confirm or deny the document's authenticity. NASA issued a statement reiterating that all available evidence is being carefully analyzed and that no conclusions have been reached regarding the object's origin or nature, the White House press. Secretary told reporters that the president had been briefed on the matter and that appropriate agencies are monitoring the situation. The careful avoidance of direct answers spoke volumes. If the object was truly safe, truly routine, truly understood, the denials would be categorical and definitive. Instead, the response was hedged, qualified, and evasive. If it's safe, why the briefing? The optical observations on Tuesday revealed structural details that had not been visible in earlier, lower-resolution images. The Hubble Space Telescope, redirected to observe 3I Atlas during a brief window of opportunity, captured images showing that the object was not a simple irregular shape. Analysis of the high-resolution data revealed linear features, straight edges, and geometric patterns that appeared artificial. The images were not released publicly. Instead, they were classified immediately upon downlink and distributed only to a restricted group of analysts. But as with previous developments, information leaked. Someone with access to the Hubble data pipeline captured screenshots and shared them through encrypted channels. The images appeared on fringe websites and conspiracy forums, where they were immediately seized upon as proof of alien visitation. Mainstream media initially ignored the leaked images, dismissing them as likely fakes or misinterpretations. But several professional astronomers who examined the images confirmed that they appeared consistent with Hubble's data format and optical characteristics. The metadata embedded in the files matched Hubble's standard conventions. The background star field was consistent with the object's predicted location. The images appeared authentic. What the images showed was open to interpretation. To some observers, the linear features were obviously artificial, straight edges, right angles, symmetrical patterns. To others, they were ambiguous, possibly natural features like fractures or layering, possibly artifacts of image processing or compression. The human eye is skilled at finding patterns, even where none exist. Pareidolia, seeing faces in clouds, animals in rock formations, is a powerful psychological phenomenon. But the patterns in the 3I Atlas images were not random. They repeated, they aligned, they suggested structure. These are not natural fracture patterns, argued one planetary geologist in a detailed analysis posted online. Natural cracks in rock and ice follow stress patterns that are curved, branching, and irregular. These features are straight. They intersect at defined angles. They show symmetry. I've spent 30 years studying asteroid and comet surfaces, and I've never seen anything like this occur naturally. If it's safe, why the geometry? The Chinese satellite repositioning happened on Wednesday without official announcement. Multiple observers tracking orbital objects noticed that several Chinese military satellites had adjusted their orbits, moving into positions that would allow them to observe the region of space where 3I Atlas would pass during its closest approach to Earth. The maneuvers were subtle but deliberate, requiring precise burns of onboard propulsion systems. Satellite tracking enthusiasts documented the changes and shared their findings through online networks dedicated to monitoring military space activities. The consensus was clear. China was preparing to observe the object closely, using assets that were nominally dedicated to Earth observation and reconnaissance, but capable of looking outward into deep space. Other countries followed suit. The United States repositioned several National Reconnaissance Office satellites. Russia adjusted the orbit of at least one classified spacecraft. Even smaller space powers made moves to optimize their observation capabilities. The global response suggested coordinated planning, shared intelligence, and unified concern. Military space assets are expensive and carefully tasked. Repositioning satellites requires fuel, time, and justification. The fact that multiple nations were willing to expend these resources indicated that 3I Atlas was considered worth the cost. This was not routine observation. This was strategic surveillance. Defense analysts speculated about the reasoning behind the satellite movements. Was this purely scientific interest, or was there a defensive component? Were nations positioning assets to gather intelligence on a potential threat, or were they preparing to respond if the object proved hostile? The questions remained unanswered, but the actions spoke clearly. Governments were taking the situation seriously, regardless of their public statements. If it's routine, why the military response? The atmospheric entry calculation appeared on Thursday in an obscure technical forum frequented by orbital mechanics specialists. Someone had taken the latest ephemeris data for 3I Atlas and extrapolated its trajectory forward, accounting for the observed acceleration and the object's evolving velocity vector. The results were unsettling. If the object continued accelerating at its current rate and direction, and if it continued making subtle course corrections, it would not simply pass Earth at a safe distance and continue into interstellar space. Instead, it would enter a trajectory that would bring it much closer, potentially close enough to interact with Earth's atmosphere or gravitational field. The calculation was speculative, dependent on assumptions about how the object's acceleration would evolve over time. But it raised a possibility that had not been publicly discussed. What if 3I Atlas was not just passing through our solar system, but was intentionally approaching Earth? The post was quickly deleted, but not before multiple users had archived it. The calculation's author, posting under a pseudonym, included a disclaimer noting that this is a worst-case scenario based on current trends and should not be interpreted as a prediction. But the underlying point was clear. If the object was under powered control, it could potentially choose to approach more closely than currently predicted. NASA's Planetary Defense Coordination Office, responsible for monitoring potential impact threats, issued a statement that evening. The statement emphasized that there is no credible impact threat from Object 3I Atlas, and that all trajectory predictions indicate the object will pass Earth at a safe distance of several million kilometers. The statement did not address the possibility of powered maneuvering or intentional approach. Planetary defense experts noted that existing impact warning systems assume objects follow predictable gravitational trajectories. If an object can accelerate and maneuver, those predictions become uncertain. The protocols designed to protect Earth from asteroid impacts are not designed for objects that can change course. "We're in uncharted territory," admitted one former planetary defense official in a media interview. "All our threat assessment models assume natural objects following ballistic trajectories. If you introduce the possibility of guided motion, you have to rethink everything. How do you predict where something will go if it can choose its own path? If it's safe, why the trajectories?" The international conference call took place on Friday. Representatives from NASA, ESA, JAXA, Roscosmos, CNSA, and several other space agencies joined a secure video meeting to discuss coordination of observation efforts and data sharing. The meeting was not announced publicly, but its occurrence was confirmed by multiple sources familiar with the participants. According to leaked minutes from the meeting, the discussion focused on establishing protocols for sharing sensitive data, coordinating observation schedules to maximize global coverage, and developing consistent messaging for public communication. Participants agreed that a unified international response was necessary to avoid confusion and ensure that all available data was being properly analyzed. One section of the minutes was particularly revealing. Under a header labeled Risk Assessment and Contingency Planning, the text noted, "Participants acknowledge significant uncertainty regarding the object's nature and intentions. Agreement reached that current observation priority is to gather sufficient data to enable informed decision-making. Contingency protocols for various scenarios under development, details to be shared through classified channels. Intentions. The word choice was striking. Natural objects don't have intentions. Rocks and comets don't make decisions." The use of this term in official documentation suggested that the participating agencies had moved beyond treating 3I Atlas as a purely natural phenomenon. The meeting concluded with an agreement to convene daily coordination calls and to establish a joint data analysis working group. Participants committed to sharing all relevant observations through secure channels and to maintaining consistent public messaging that would inform without alarming the global population. One attendee, speaking anonymously to a journalist, characterized the meeting as sobering and necessary. According to this source, the mood was professional but tense, with everyone aware that they were dealing with a situation unlike anything in the history of space exploration. If it's routine, why the coordination? The optical navigation analysis was completed over the weekend and immediately classified. Optical navigation is a technique used by spacecraft to determine their position and velocity by measuring the angles to known stars and solar system objects. It's how autonomous spacecraft know where they are without constant communication with ground controllers. A team of image processing specialists had analyzed the high-resolution Hubble images of 3I Atlas, looking for any evidence of attitude control or orientation changes. What they found was subtle but significant. Between two images taken 6 hours apart, the object had rotated slightly, but not in a way consistent with passive tumbling. The rotation appeared controlled, with specific surface features pointing toward the Sun during the first image and toward Earth during the second image. The analysis suggested that the object was actively controlling its orientation, pointing different sides toward different targets as it moved through space. This is exactly what a spacecraft would do: orient solar panels toward the Sun for power generation, point antennas toward communication targets, aim instruments toward objects of interest. The report concluded with careful language. Observed rotational dynamics are inconsistent with passive mechanical tumbling. Orientation changes suggest possible active attitude control. Natural explanations cannot be excluded, but require invoking unlikely coincidences in timing and geometry. The report was marked secret and distributed to a restricted list of recipients. Its existence became known only through second-hand accounts and oblique references in subsequent discussions among cleared personnel. If it's safe, why the control? By Monday morning, the public narrative had shifted perceptibly. While official statements continued to describe 3I Atlas as under routine observation, media coverage had become increasingly speculative. Science journalists who had initially covered the story as a minor curiosity were now writing feature articles exploring the possibility of artificial origin. Television news programs interviewed astrobiologists about the implications of discovering evidence of extraterrestrial technology. Public interest surged. Opinion polls conducted during this period showed that a significant percentage of people believed that governments were not being fully transparent about the object. Trust in official statements was declining as the gap between official language and observed behavior became more apparent. Social media filled with speculation, ranging from sober analysis to wild conspiracy theories. The situation put space agencies in an impossible position. They could not definitively rule out the artificial origin hypothesis because the data supported that possibility. But they also could not confirm it without absolute certainty, as the consequences of a false positive would be enormous. So they maintained their carefully calibrated position of acknowledging uncertainty while urging caution against premature conclusions. "We're watching this object very carefully," said NASA's administrator during a rare press conference. "We're using every available tool to gather data and understand its nature. What I can tell you is that we take this seriously. We're coordinating with international partners, and we will share information as it becomes available and appropriate. Right now, we're still in the observation and analysis phase." When pressed about whether the object might be artificial, the administrator chose words carefully. "We follow the evidence wherever it leads. Our primary hypothesis remains that this is a natural object with some unusual characteristics, but science requires that we remain open to all possibilities and let the data guide our conclusions." The non-denial was as close to confirmation as official channels would provide. If it's safe, why the ambiguity? The spectroscopic breakthrough came on Tuesday from an unexpected source. A university observatory in Australia, operating outside the NASA coordination network, had been conducting its own independent observations of 3I Atlas. Using a spectrograph designed to detect faint absorption and emission lines in distant objects, they captured data that revealed something remarkable. The spectrum showed absorption features consistent with refined materials, elements in combinations and concentrations that don't occur naturally in space. Specifically, the data showed signatures of processed metals, alloys, rather than pure elements. Natural space objects contain metals in roughly solar proportions, mixed with rock and ice. The spectroscopic signature of 3I Atlas suggested deliberate composition, materials that had been extracted, purified, and combined. The Australian team published their findings on a preprint server before consulting with major space agencies. The paper's title was direct: "Anomalous Spectroscopic Signatures in Interstellar Object 3I Atlas Suggest Non-Natural Composition." The abstract laid out the evidence methodically. Detection of aluminum-lithium alloys, titanium compounds in unexpected ratios, and trace signatures of rare earth elements in configurations not found in natural astronomical bodies. "These compositional characteristics are consistent with aerospace-grade materials," the paper concluded. "While we cannot definitively determine the object's origin from spectroscopic data alone, the presence of processed alloys strongly suggests manufacturing rather than natural formation." The paper went viral within hours. Media outlets seized on the findings as the strongest evidence yet for artificial origin. Scientists immediately began debating the interpretation. Could contamination explain the results? Could exotic natural processes produce these signatures? Were the measurements even reliable? NASA's response was swift. A statement noted that preliminary spectroscopic data requires careful verification and peer review, and cautioned that unusual spectroscopic signatures have been reported for natural objects before, only to be later explained by conventional processes. The statement did not directly dispute the findings, but emphasized the need for confirmation and alternative interpretation. Behind the scenes, NASA and other space agencies scrambled to replicate the observations using their own instruments. Within 24 hours, multiple independent facilities had confirmed the detection of the anomalous absorption features. The Australian team's findings were accurate. The object showed spectroscopic signatures consistent with refined materials. If it's safe, why the alloys? The radio transmission was intercepted on Wednesday at 3:47 a.m. Universal Time. The Deep Space Network facility in Madrid, Spain, operating in receive-only mode as part of routine monitoring operations, detected a signal originating from the direction of 3I Atlas. The signal was narrowband, frequency stable, and lasted 14 minutes before ceasing abruptly. The transmission was not expected. The object had shown no prior evidence of active radio emission. The frequency 8.4 GHz was commonly used for deep space communications, suggesting deliberate choice rather than natural emission. The signal showed clear structure, periodic amplitude modulation with a complex pattern that repeated every 37 seconds. The DSN facility immediately alerted NASA headquarters. Within minutes, other ground stations were redirected to point toward the object's location, hoping to capture additional transmissions. None were detected. Whatever the signal had been, it was a brief, isolated event. The signal data was classified immediately, but the fact of the detection could not be completely hidden. Radio astronomers outside the NASA network who had been monitoring nearby frequencies noticed unusual activity in the DSN operations log. Questions were asked. Carefully worded denials were issued. Rumors spread. One anonymous source described the signal as clearly artificial in origin. According to this source, the modulation pattern was too structured to be natural noise, too organized to be random interference. It was information, the source claimed. Whether it was meant for us or for something else, I can't say. But it was definitely a transmission. Analysis of the signal structure revealed tantalizing hints. The 37-second repetition period was unusual, not a common human standard time unit, but potentially significant in other contexts. 37 is a prime number, which some researchers noted could be a universal choice for a repeating signal designed to be recognized as artificial. The modulation pattern included what appeared to be a series of pulses with varying amplitudes, potentially encoding information in some unknown format. Cryptanalysts at the National Security Agency were brought in to examine the signal. Their analysis reportedly concluded that the pattern showed statistical properties consistent with encoded data, but without a key or context, decryption was impossible. The signal could contain anything from telemetry data to a message, or it could be pure noise that happened to have structure. If it's routine, why the transmission? The magnetic field detection was published on Thursday in a brief technical note by a team of space physicists monitoring the solar wind. Using data from spacecraft positioned throughout the inner solar system, they had been tracking disturbances in the interplanetary magnetic field, the weak magnetic field carried by the solar wind as it flows outward from the Sunday. As 3I Atlas moved through the solar system, it appeared to be affecting the magnetic field in its vicinity. The disturbance was small but measurable. A localized region of enhanced and distorted magnetic field lines surrounding the object, extending roughly 1,000 kilometers in all directions. This magnetic signature was not consistent with any known natural phenomenon. Natural space objects don't generate significant magnetic fields unless they contain large amounts of magnetic minerals or have internal dynamos like Earth's core. The spectroscopic data showed no evidence of magnetic minerals in sufficient quantity. And a small object like 3I Atlas, even if it contained a metallic core, would have cooled billions of years ago, extinguishing any primordial dynamo effect. The magnetic signature suggested active field generation, something inside the object, producing a magnetic field, either as a byproduct of electrical systems or as a deliberate mechanism for some purpose. Spacecraft use magnetic field generators for attitude control, for deflecting charged particles, for creating protective bubbles against radiation. The magnetic signature of 3I Atlas resembled, in miniature, the protective magnetic field around a planet or spacecraft. This is not a passive object, concluded the technical note. The presence of an active magnetic field indicates ongoing electromagnetic activity inconsistent with a dormant, natural body. The paper was submitted to a journal but never published. According to one of the authors, the editorial board received a request from relevant authorities to delay publication, pending coordination with ongoing research efforts. The paper remained in submission limbo, its findings known to specialists but not widely disseminated. If it's safe, why the field? The visual observation from the International Space Station occurred on Friday and was captured on personal camera equipment by one of the crew members. The astronaut had been photographing Earth's limb, the curve of the planet's atmosphere against the blackness of space, when they noticed an unusual object in the frame. Upon review, the images showed a small, bright point moving against the star background, visible for approximately 20 seconds before passing out of the camera's field of view. The astronaut reported the sighting to Mission Control, describing it as much brighter than expected for something that far away. Based on the timing and direction, analysts determined that the object was almost certainly 3I Atlas, photographed during a chance alignment that brought it into the ISS's field of view. The photographs were technically impressive. Despite being taken with consumer equipment through a spacecraft window, they showed the object with sufficient detail to confirm several features. The object appeared elongated, with a distinct, non-uniform brightness distribution. One end appeared brighter than the other, and there were hints of structure, linear features that matched the patterns seen in the Hubble images. Most remarkably, the photographs captured something that previous observations had missed or had not been able to confirm. The object appeared to be venting material from one end. A faint, narrow stream of gas or particles extended behind the object, visible because it reflected sunlight slightly differently than the surrounding space. This was the first visual evidence of any kind of exhaust or emission from the object. The discovery reignited debate about the object's nature. Supporters of the natural origin hypothesis pointed to the venting as evidence of cometary activity, proof that the object was outgassing and that this explained the non-gravitational acceleration. Critics noted that the vent appeared to be coming from a specific point rather than from the entire surface, and that it was directional rather than radial, more consistent with a thruster than with sublimating ice. "Comets don't have nozzles," one planetary scientist commented when reviewing the images. "They have active regions that vent when sunlight heats the surface, but those vents are diffuse and irregular. This looks collimated, like a jet engine. That's not how nature works." The ISS images were initially withheld from public release, then published with minimal commentary. NASA's official statement noted that the images show evidence of material emission from the object, consistent with some form of active process. The statement did not speculate about whether the emission was natural or artificial. If it's safe, why the exhaust? The weekend brought an escalation in government activity. Multiple sources reported increased security at space agency facilities, expanded staffing at planetary defense coordination centers, and high-level briefings involving senior government officials. The United Nations Office for Outer Space Affairs convened an emergency session, closed to the public, to discuss international response protocols. Military installations worldwide went to heightened alert status, not publicly announced but visible to those who monitor such things. Additional radar assets were brought online, surveillance satellites were repositioned, and missile defense systems in several countries underwent readiness checks. None of these activities were explicitly linked to 3I Atlas, but the timing was conspicuous. Civil defense agencies in some countries quietly updated their emergency response plans, adding sections on unconventional space events and reviewing communication protocols for mass notification. These updates were not publicized, but documents leaked through government transparency channels revealed the nature of the preparations. The pattern was unmistakable. Governments were preparing for the possibility that 3I Atlas might be more than a scientific curiosity. Whether the threat was real or merely precautionary, authorities were taking steps to ensure they could respond to various scenarios. The specific nature of those scenarios remained classified, but the scale of preparation suggested serious concern. Public awareness of these activities increased anxiety. Social media filled with worried speculation. Some voices called for calm and rationality, noting that precautionary preparation did not necessarily indicate imminent danger. Others demanded transparency and accused governments of concealing information. The tension between security and disclosure created a difficult balancing act for officials trying to manage public perception while preparing for uncertain possibilities. If it's routine, Why the preparation? The computational simulation results were completed on Monday by a team at Los Alamos National Laboratory. Using advanced modeling techniques, they had attempted to determine what kinds of structures could produce the observed characteristics of 3 I Atlas: the size, mass, thermal signature, magnetic field, and acceleration profile. The simulation tested hundreds of scenarios, varying composition, structure, and internal systems. Natural configurations were explored first: solid rock, porous ice, rubble, pile asteroids, comet nuclei with various compositions. None of these natural models could reproduce all the observed features simultaneously. Either the mass was wrong, or the temperature was wrong, or the magnetic field couldn't be explained. The team then explored artificial structures. They modeled a hollow shell with internal systems powered by a compact energy source. They varied the shell thickness, material properties, and power system characteristics. By adjusting these parameters, they found configurations that matched all the observations within measurement uncertainties. The simplest explanation that fits the data, their report concluded, is a manufactured object, a shell structure composed of lightweight alloys, containing active systems that generate power, produce magnetic fields, and provide propulsion. Mass estimates suggest mostly empty internal volume, consistent with a vessel or probe rather than a solid body. The report included detailed technical appendices, pages of equations and tables comparing model predictions to observed values. The mathematical analysis was rigorous and professional. The conclusion was unavoidable. If you wanted to build something that looked like 3I Atlas, you would build a spacecraft. The Los Alamos report was classified secret and distributed only to senior officials and cleared scientists. Its existence became known through second-hand references and oblique mentions in subsequent discussions. The full report was never released publicly, but its conclusions leaked through multiple channels, each leak adding to the growing body of evidence that pointed in one direction. If it's safe, why the spacecraft model? The Amateur Telescope Network captured the flash on Tuesday night. A group of coordinated observers, frustrated by official secrecy and determined to gather their own data, had organized a global observation campaign. Dozens of amateur astronomers with backyard telescopes in multiple time zones maintained continuous watch on the object, sharing data in real time through online platforms. At approximately 23:15 UTC, observers in North America and Hawaii simultaneously reported a sudden brightness increase. The object, normally visible as a faint point requiring long exposures to detect, became briefly bright enough to see in moderate-sized telescopes with short exposure times. The flash lasted approximately 8 minutes, during which the object's brightness increased by a factor of 5 before returning to normal levels. Photometric analysis of the flash revealed that it was not a reflection or glint. The brightness increase was too prolonged and too smooth. Spectroscopic data captured during the flash showed an emission spectrum dominated by thermal radiation, consistent with something being heated to high temperature. The color temperature corresponded to approximately 3,000 Kelvin, hot enough to glow visibly, far hotter than any natural heating mechanism could explain at that distance from the Sunday. Something inside that object got hot, observed one of the amateur astronomers who witnessed the flash. It wasn't the whole object the thermal profile suggests. A localized heat source, maybe an engine burn, maybe a power surge, maybe some kind of internal system activating. Whatever it was, it produced enough energy to make the whole object brighter for several minutes. Official observatories that happened to be watching confirmed the event. NASA acknowledged that a transient brightening event was observed and stated that analysis is ongoing to determine the cause. No further explanation was provided. The timing of the flash was interesting. Orbital calculations suggested that it occurred shortly after the object had completed a small course correction, adjusting its trajectory slightly to refine its approach to Earth. The flash might have been the visible signature of that maneuver, a propulsion burn or attitude adjustment producing waste heat that made the object temporarily brighter. If it's routine, why the flash? The close approach date was now confirmed, 6 days away. On Monday of the following week, 3I Atlas would reach its closest point to Earth, passing at a distance of approximately 0.04 astronomical units, about 6 million kilometers, roughly 15 times the distance to the Moon. In astronomical terms, this was extremely close for an interstellar object. It would be the nearest approach of any confirmed interstellar visitor in recorded history. Space agencies around the world prepared for the encounter. Observation schedules were maximized, with every available telescope allocated time to study the object during its closest passage. Ground-based radar systems were positioned to bounce signals off the object, measuring its size and shape with precision. Spacecraft throughout the solar system were tasked to observe from multiple angles, providing parallax measurements and multi-wavelength coverage. The level of preparation was unprecedented. Never before had the global astronomical community coordinated so intensively to observe a single object. The effort rivaled major solar system exploration missions in scope and complexity. Thousands of scientists, hundreds of facilities, uncounted hours of telescope time, all focused on one small, dark object moving through space. Media coverage intensified. News networks established countdown clocks showing the time remaining until closest approach. Special broadcasts were planned. Experts were scheduled for interviews. The public's attention was fully captured. Whatever 3I Atlas was, humanity would get its best look at the object in less than a week. Government officials prepared briefings for various scenarios. If the object proved to be natural, the data gathered during close approach would provide invaluable scientific insights. If the object proved to be artificial, the close approach would be humanity's first confirmed encounter with extraterrestrial technology. Either outcome would be historic. Behind closed doors, military and intelligence officials considered darker possibilities. What if the object was a threat? What if close approach was a prelude to hostile action? What if the object was a weapon rather than a probe? Contingency plans were developed for scenarios that few wanted to contemplate, but none could completely dismiss. The tension was palpable. The world watched and waited. If it's safe, why the countdown? The optical anomaly was detected on Wednesday by multiple observers simultaneously. During a coordinated observation session, telescopes in 3 different countries, Chile, Australia, and South Africa, all captured images showing something new. The object was no longer alone. A second, much smaller point of light was visible nearby, moving in formation with 3I Atlas, but separated by approximately 2,000 kilometers. Initial speculation suggested that the object had fragmented, breaking into 2 pieces. But closer analysis ruled this out. The 2 objects maintained a fixed separation as they moved through space, not drifting apart as fragments would. They were traveling together, their motions coordinated, suggesting that they were connected by more than coincidence. The smaller object was much fainter, perhaps 1/10 the size of the main body. Its appearance was sudden. Previous observations had not shown any companion. Either it had been hidden behind the main object and was now visible due to geometric alignment, or it had separated from the main body recently. One possibility generated intense speculation. The smaller object might be a probe or sub-satellite deployed from the main craft to conduct reconnaissance or fulfill some specific function. Spacecraft often carry smaller vehicles for dedicated tasks: landers, rovers, communication relays. The appearance of a companion object would be consistent with a mothership releasing a subsidiary component. NASA's statement acknowledged the detection of a secondary object in proximity to 3I Atlas and noted that the relationship between the 2 objects is under investigation. The statement avoided speculation about the cause or purpose of the configuration. Radio observations attempted to detect any signals between the 2 objects, any communication or data transfer. Nothing was detected in the monitored frequencies, but the objects might be communicating using methods or frequencies beyond current monitoring capabilities. The discovery of a companion object transformed the situation. If 3I Atlas had been alone, it might be explained as a natural object with unusual properties. but a coordinated pair suggested deliberate action, planning, purpose. If it's safe, why the companion? The thermal plume was imaged on Thursday by an infrared space telescope designed to detect faint heat signatures. The images showed a narrow stream of warm material extending from the main object, pointing backward along its trajectory, exactly what you would expect from an engine, exhaust, or propulsion system. The temperature of the plume was approximately 400 Kelvin, warmer than the background space but not extremely hot, consistent with a low-thrust, high-efficiency propulsion system. The plume extended for several thousand kilometers before dissipating, gradually cooling and dispersing as the material spread and radiated away its heat. This was no longer ambiguous. An object producing a directed thermal plume is using powered propulsion. The physics were unambiguous. Momentum must be conserved, and the only way to accelerate an object in space is to eject mass in the opposite direction. The thermal plume was that ejected mass, heated by whatever process was producing thrust. Engineers analyzing the plume characteristics estimated the thrust level at approximately 1 to 2 kilonewtons small by the standards of chemical rockets, but substantial for electric propulsion systems. The estimated mass flow rate and exhaust velocity suggested a high specific impulse propulsion technology, possibly ion drive or similar electric propulsion. This is a spacecraft, concluded one propulsion engineer, reviewing the data. There's no longer any doubt. It has an engine. It's producing thrust. It's maneuvering. Whether it's alien or not, I can't say. But it's definitely artificial. The infrared images were presented at a closed briefing attended by senior government officials. According to leaked accounts, the reaction was a mixture of awe and concern. The reality of the situation was now undeniable. Humanity was being visited by an object that was not natural, not passive, and not simply passing through. It was navigating, maneuvering, approaching. The question was no longer, is it artificial? The question was, what does it want? If it's safe, why the engine? The communication attempt began on Friday. Multiple space agencies coordinated to transmit radio signals toward 3I Atlas, using powerful deep space transmitters to broadcast messages on frequencies considered potentially universal, the hydrogen line, mathematical constants, prime number sequences. The effort was not publicized in advance, but was confirmed after the fact through official statements describing the initiative as attempting to establish communication with an object of potentially artificial origin. The transmissions included basic mathematical and physical concepts, representations of human civilization, and simple queries. Are you receiving this? Who are you? What is your purpose? The messages were repeated in various formats and frequencies, hoping that if the object was indeed a probe or vessel, it might recognize the attempt at contact and respond. No response was detected. The object continued on its trajectory, continued its approach, showed no reaction to the transmissions. Either it was not equipped to receive or decode the signals, or it chose not to respond, or it was not interested in communication. The silence was unsettling. If the object was a natural phenomenon, silence was expected. But if it was artificial, silence suggested either incomprehension or deliberate choice. Neither option was comforting. Some scientists argued that expecting a response was naive. An alien intelligence might not recognize human communication attempts, might use completely different protocols and concepts, might not even perceive electromagnetic radiation in ways humans understand. Communication with an extraterrestrial civilization, if that's what this was, would require patience, creativity, and luck. Others suggested that the lack of response indicated that the object was autonomous, following programmed instructions without capacity or need for dialogue. An automated probe from another civilization, sent millions of years ago to explore the galaxy, might have no interest in communicating with the primitive species it encountered. It would simply gather data, fulfill its mission, and move on. The weekend brought the final countdown. Less than 72 hours remained until closest approach. Preparations were complete. Telescopes were aligned. Observation schedules were finalized. Governments had briefed their citizens with carefully worded statements urging calm and emphasizing that all precautions were in place. The world held its collective breath. If it's safe, why the attempt? The final trajectory update appeared on Saturday morning. The object's path had been refined based on the latest astrometric measurements, and the results were simultaneously reassuring and disturbing. The closest approach distance had increased slightly. 3 I-Atlas would pass at 0.043 astronomical units instead of 0.04, a difference of about 500,000 kilometers. This meant less danger of any gravitational interaction or potential impact. The object would safely miss Earth. But the trajectory refinement also confirmed what many had suspected. The object's course was not a simple hyperbolic flyby. It was approaching Earth along a precisely calculated path that would bring it close enough for detailed observation, but not so close as to pose collision risk. The trajectory showed all the hallmarks of deliberate navigation, a carefully planned approach that maximized observational opportunities while maintaining safety margins. "This is a reconnaissance pass," observed one orbital mechanics specialist. "The object is flying by Earth at optimal distance and velocity for detailed observation. If it were natural, it would be pure coincidence for it to happen this way. But it's not coincidence. This trajectory was planned. The implications were profound. If the object was approaching deliberately, with purpose and navigation, then someone or something had sent it to study Earth. We were being examined, investigated, perhaps evaluated. The object was not a random visitor. It was here specifically to look at us." The realization transformed the situation from scientific curiosity to potential contact scenario. This might be humanity's first interaction with intelligence from beyond Earth. Not a message received from distant stars, not ancient artifacts found on another world, but an active probe, here and now, studying our planet. What would it see? What would it learn? What would it report back to its creators, if creators existed? The questions spiraled outward into uncertainty and wonder. If it's safe? Why the reconnaissance? The Sunday briefing to world leaders was confirmed through multiple diplomatic sources. Presidents, prime ministers, and monarchs were informed of the latest assessments and the planned observations during the Monday encounter. The briefings emphasized that no immediate threat was expected, but that the situation was unprecedented and unpredictable. Military commanders were given updated rules of engagement. Observe, monitor, but do not interfere unless the object demonstrates hostile intent. No weapons were to be aimed at the object. No provocative actions were to be taken. The approach would be passive, scientific, and peaceful. But preparations were made for other possibilities. Missile defense systems were quietly placed on standby. Surveillance networks were maximized. Command centers were staffed around the clock. If the situation changed, if the object proved dangerous, responses would be available. The public messaging remained consistent. Curiosity, not fear. Wonder, not panic. Humanity was witnessing a historic event, a milestone in our species' long journey of exploration and discovery. Whatever 3i Atlas was, whatever it represented, this was a moment to be experienced with open minds and rational thought. Late Sunday evening, NASA's administrator addressed the world in a televised statement. The message was brief, measured, and historic. "Tomorrow, an object from beyond our solar system will pass close to Earth. We have learned much about this object over recent weeks. We know it is unusual. We know it exhibits characteristics that challenge our understanding. We do not yet know definitively what it is, but we are watching carefully, gathering data, and preparing to learn as much as we can. Whatever we discover tomorrow will inform humanity's future. If the object is natural, we will gain insights into the physics and chemistry of interstellar space. If it is artificial, we will have confirmed that we are not alone in the universe. Either outcome is profound, I encourage everyone to follow the observations through the channels we will provide. This is a moment for our species to come together in curiosity and wonder. Let us face this event with courage, wisdom, and hope. The statement was carefully crafted, acknowledging uncertainty while projecting confidence. It prepared the public for revelation without committing to specific conclusions. It was a masterpiece of diplomatic communication, saying everything and nothing simultaneously. The world went to sleep on Sunday night, knowing that Monday would bring answers. Whatever 3i Atlas was, whatever it meant, the mystery would soon be resolved. If it's safe, why the statement? Monday morning arrived with clear skies and tense anticipation. Telescopes around the world locked onto the predicted coordinates, tracking the object as it raced across the sky at 12 kilometers per second. High-resolution cameras captured every detail. Spectrographs analyzed every wavelength. Radar systems bounced signals off the object's surface, building three-dimensional models of its structure. The data flooded in, overwhelming analysis systems, filling servers, creating the most comprehensive observation of an interstellar object ever achieved. Scientists worked frantically to process the information, to extract meaning from the tsunami of measurements. And as the hours passed, as the object reached closest approach and began to recede, as the detailed observations revealed the full truth, the world learned what NASA had suspected but couldn't confirm until now. 3i Atlas was a spacecraft. The evidence was irrefutable. The structure was a thin shell, clearly manufactured, covered with geometric patterns and surface features inconsistent with natural formation. The propulsion system was visible in infrared, a glowing core producing steady thrust. The magnetic field surrounded it like an invisible cocoon, deflecting charged particles. The radio emissions included structured signals, potentially telemetry or data transmission. Most remarkably, the high-resolution images showed markings, symbols etched into the surface, arranged in patterns that suggested language or notation. The symbols were not human, not anything from Earth's cultural heritage. They were alien. Humanity had been visited. We were not alone. The realization spread through command centers, laboratories, and living rooms around the world. The object wasn't just passing through. It had come here, to this planet, to observe us. And now it was leaving, carrying whatever data it had gathered back to wherever it came from. The questions multiplied. Who sent it? When? Why? Would there be more? Would they return? Should we be excited or terrified? What did this mean for humanity's future? NASA held an emergency press conference Monday evening. The room was packed with journalists, cameras, and recording devices. The administrator stepped to the podium, took a breath, and spoke with measured words. Today we observe the closest approach of interstellar object 3i Atlas. Based on comprehensive analysis of the data collected, we can confirm that the object exhibits characteristics consistent with artificial origin. We believe we have been visited by a probe from another civilization. This is the first confirmed detection of technology from beyond our solar system. The object has now passed Earth and is departing on an outbound trajectory. It poses no threat. It made no attempt to communicate beyond passive electromagnetic emissions. It simply observed and is now leaving. This discovery changes everything we thought we knew about our place in the universe. We are not alone. Somewhere, someone else exists. Somewhere, someone else builds spacecraft and sends them across the stars to explore. Somewhere, someone else looked at our sun and wondered what might be found here. We do not know where they are. We do not know who they are. We do not know when they sent this probe or why, but we know they exist. And that knowledge will guide humanity's future as we continue our own journey into space, hoping one day to meet them. The statement concluded, but the questions had only begun. The press conference lasted 3 hours, with the administrator and senior scientists fielding countless inquiries about the discovery, its implications, and what comes next. And as Monday turned to Tuesday, as 3I Atlas continued its journey back into interstellar space, carrying its data and its secrets, humanity was left with wonder and uncertainty in equal measure. They called it harmless. Then they changed the classification. And now every telescope on Earth has gone dark. Whatever 3I Atlas is, it's no longer background noise. It's priority one. It's proof. It's a visitor from the stars, a messenger from the void, a reminder that the universe is vast and full of mysteries we're only beginning to understand. And somewhere in the darkness between stars, whoever sent it now knows we're here. They know we exist. They've seen us. They've measured us. They've recorded us. And perhaps, someday, they'll return. If it was safe, why are we still watching the sky?